Recording. All right, welcome everybody to today's webinar. I'm joined by some world-class folks that you all are probably very familiar with. I got Lionel and Dustin. How you guys doing?
Hello.
Doing great. Happy Monday, everyone.
Yeah. Welcome to the webinar, everybody. We miss our buddy Ellie. She's out on vacation today, so wherever you are, Els, hope you're having a good time, relaxing, enjoying yourself. Peace to you. Okay, so today's webinar, before we get started, we get some housekeeping. Let's do some housekeeping really quick. So one of the questions we get asked most often, more than anything else, is like, are we going to record this session? And yes, we always record everything, and it's going to be posted here to the Maxon Training Team YouTube channel. So this session will be live later today or tomorrow, and I'm going to be going really fast today. So yeah, remember that. You're going to want to probably come back to this thing because it's going to be like very, very quick and breakneck speed. Also, if you want to go to the Maxon events page, which you can do by going to the news page here, go to events, and then you can see all of the things that we have coming up. So here's like today's thing, but we're also doing an awesome Ask the Trainer on Thursday. We have VFX and Chill with Hashi and Seth on Friday, and all kinds of shows. Next month, we're going to start doing a 5-part series on shooting. So planning for a shoot, shooting on set, and working with like challenges on set, and shooting for the grade, and actually doing the grade, and visual effects, and all that kind of stuff. And of course, you have Maxon Color, all kinds of really great shows we have for free all the time. So be sure and check that page out as well. And then also, you'll notice in the links on in your GoToWebinar thing, there should be like a links area or a handouts area, depending on which interface you're using. But there's a PDF here, and in this PDF, there's a link to a store where you can get a free t-shirt for the rest of the month. The password is Particle Magic, but you have to use this link, and you have to use the password, and then you just have to pay for shipping for the shirt, and you get a free shirt out of that. Did I miss anything, guys? I wasn't planning on doing the housekeeping stuff at the beginning, so then I'm like all nervous and sketchy and like, ooh.
No, you got it.
I think we got it. I think it's covered.
Yeah.
Okay. Good. Okay, well, today we're going to do something really unconventional. We're going to look at Houdini and Particles Houdini. We talk about particles all month. So we're going to take the most of today, and we're going to be looking at just kind of like the basics of Houdini, because we figure maybe a lot in our audience are not familiar with it. So we're just going to do some basics of Houdini if you're not familiar, and then we're going to get a little bit into particles and see the amazingly complex and powerful world of particles there. And then the last few minutes, we're just going to very briefly look at particles in Unreal Engine as well. We'll talk about why you might want to do that. So we're going to start out in Houdini. There will probably be a lot of questions because I'm going to be going really fast. So feel free to interrupt me, guys. But also, if you miss something, you probably have to catch the recording because, again, it's going to be going pretty fast. It's a pretty complicated program that works very differently than other DCC programs that you might be used to. So here's basic Houdini. By the way, Houdini, there is a free version of Houdini. It's pretty powerful. You could do all the stuff you can in normal Houdini, but you can't output stuff very well. You can't send BDBs out. You can't export EXRs. So there's some limitations there, and the maximum render size is like 720p, and it has a watermark. But they also have an indie version, which is like pretty cheap as well. So here's the interface when you first launch Houdini. We have these panels, and I'm not going to take too long talking about the interface, but it's very, very flexible. So you can right-click on any panel, and then when you right-click on the name of a panel, you can change it to anything else. So what I do, and I don't know if this is the default or not, but I change my top thing to network view because this is where you see your objects. And then once you have a selected object, you get its properties. I put my parameters panel down there because this is where we see the properties of what's selected. And I set up my interface like this so that it mirrors Cinema 4D, which is like where I'm comfortable. That's home for me. So this is almost like the objects manager where we have our objects here. And then this is almost like our attributes manager, the parameters panel. So it kind of mirrors, again, what we do in Cinema. And just very briefly, we also have up here at the top these presets that are great for new people to Houdini. And these have common things like cameras and lights, but they also have presets. So if I go to the particles shelf, then you could see that we have like fireworks. So I can just click on fireworks here, and then oftentimes I'll get a cursor. My cursor changes to this kind of updating weird thing. And I just have to click to say where I want those fireworks in this case. Then if I press the up arrow to play this, you could see that we have fireworks in our scene now. So they're exploding. And a lot of these presets are, you know, jumping off points. A lot of them can be great complete things. Like if I go to terrain effects on the left side, there's, you know, canyons that we can add. There's a moonscape, there's dunes, there's all kinds of really great terrain tools in Houdini as well. So so here we have some fireworks to play with. If I press Control or Command up arrow, it rewinds the playhead back to the beginning. So again, up arrow plays and pauses. There we go. And navigation controls are similar. If I hold the Alt key and left mouse button, click and drag, we can rotate around. Middle mouse button is for panning, and right and Alt click, right button and Alt click can zoom in and out. So let me go ahead. I'm just going to create a new document, throw that away, start from scratch. So one of the first things you'll want to do when you're in Houdini is go to this network view panel, and you press tab to create a new node. And this is one of the things that intimidates a lot of new users about Houdini, is that we don't typically just like work in the viewport like we do in other DCC apps. We work with nodes. And so a lot of people are intimidated by that, but actually, I mean, Houdini is a very intimidating app, but that's not the most intimidating aspect of Houdini, as we'll see. You get used to the nodes pretty quick. It's pretty flexible and pretty great. So the first thing I want to do is I'm going to type geometry, because typically what you're doing in Houdini and when you first start out is creating a geometry node. And you might say, well, what did you just create? What geometry is there? Because there's nothing that's going on. And that's true. We just created a geometry network. So if I double click my geometry network, it's like we've gone down the rabbit hole and we're in a different world. And so you'll notice if I press the U key to get back to the object level, or I can just click here or click U, I'm back here in the object level. It says objects, and then I double click it, and now I'm in the geometry context. And the nodes, if I go up here, I press tab, and let's say I'm in, like, so I'm in the object level, I'm at the top level, and you see if I go to primitive, I have, what, like 8 things, 7, 8 things, I can't count, but basically just like a handful of things. But if I go into my geometry context, hit tab again, then we go to primitive, you see we have tons of other objects. And this is kind of another aspect of Houdini that is a little bit new and different and confusing. So I've got this like little presentation here, thing that I made about this to explain the idea of Houdini networks. Okay, got the spinning ball of death here. And any questions so far? Did I miss anything?
No question yet.
Okay.
Well, you're using Houdini 19.0 and there's 19.5, but it's brand new. I think it was just released a few days ago, so Redshift will be updated very soon, I guess. So yeah, it's working now.
Okay, good to know. Thanks. Yeah, I haven't updated to 19.5 yet. That's always like a challenge for me. And maybe I'll explain why that is in a minute. But yes, thank you for pointing that out. So let's talk really briefly about Houdini networks, because this is something that throws new users for a loop. We have, in some contexts, like when we're in the geometry context, like we just saw, we have something called standard operators. That's what we call the nodes when we're in the geometry network. We call them standard operators. But there are tons of other networks. Okay, After Effects is in trouble, I think. If rendering text takes that long, we're in trouble. So then we also have oh, sorry, go ahead.
No, go ahead. It's too many software open at the same time, I guess. Like you said, you had Unreal, Houdini, and After Effects. Yeah, that's being tough on the computer.
It is being tough on the computer. So I have these with Houdini and with Epic, I have like these like licensing issues all the time. So whenever I go to open them, they often will not open. And so I have everything open just so like there's no messing up anything. So I wanted everything just to be set as it was, so we weren't sitting here for like 20 minutes waiting for me to resolve my licensing issues before continuing on. So things are going a little bit slow, and I apologize for that. So then we have like render operators, we have dynamics operators. In a dynamics context, we have channel operators, we have depositing operators. And each one of these is in its own network. So in the same way we had the object network and then we had the geometry network, those are all kind of like their own separate worlds in Houdini. And all of those nodes behave differently. There are different rules for the nodes. And not only are there different nodes available in each of these contexts, but they behave differently. And the rules, again, are different. So one of the things that's good to know when you're new to Houdini is the nicknames that the community has given to these nodes. So when we're in the geometry context, those standard operators, these basic nodes, we refer to them as SOPs for short. So standard operators abbreviated as SOPs. So we call those nodes SOPs. And if you're in the rendering context, we call those nodes ROPs, DOPs, CHOPs, COPs, LOPs, MOPs. There's a million of these things. So if you ever hear like something that rhymes with op, like that's what it is. It's an operator for a particular context of Houdini. I was going to go through some of the stuff that I've made in Houdini just to give it a sense of some of the stuff that I've done, and also so I could talk through kind of like what Houdini brings to the table, because after today, you might be like, why would anyone want to use Houdini? Because it's ridiculously complicated and it takes the most simple actions sometimes and makes them so incredibly, insanely complicated. But you do get a lot of control. And I like that. So I made this thing. It's like one of the only things I've ever made in Houdini that I like, because I'm still pretty new at Houdini. But this was all made with lines of code. So I used code to generate the swirls, the shape of the swirls. And then also on the swirls themselves, the beveling and the width were created and generated and controlled by code that I wrote. And then also like the leaves, the shape of the leaves, the ridges of the leaves, the beds of the leaves, this is all with a bunch of, same thing with the flowers, it's all just a bunch of code. And then I have control over all of those things. So it is a lot of hassle and a lot more time to set up than it would be in any other program, especially Cinema. But I do have a lot of power and a lot of control there, which is pretty fun. And I also use Houdini a lot for volume stuff, which it does really well. So I made like this like ink thing that After Effects is not going to render because it's going really slow. I also did this like little experiment with like colored smoke that also won't render, but it's pretty cool looking stuff. And you can imagine what that looks like. Just imagine it being really cool. And then today we're going to be digging into creating kind of like these basic moving particles, which again, in a lot of apps, this would be very, very easy. But in Houdini, it's going to be a little bit of a challenge, but it's going to be really powerful as well. So we're going to start with the basics and kind of like work our way up to this. I'm going to go ahead and close After Effects so that it's not draining my resources. And then I created a Houdini file that we're going to use. It's already set up. And here we go. Okay, so I've created a bunch of geometry nodes. And so I'm going to start with intro and merge. I made this shareable, I think. Yeah, so if anybody wants this, like let us know and I can share this HIP file with you. I am using Houdini effects, so I'm not sure if this would work in the free version or the indie version. I don't believe that it would, but this file is there if you want to use it. So I'm going to go into intro and merge, and we're just going to start talking about just basics here. So I'm in the geometry context. Again, I hit tab to look for nodes to use, and I'll type in box, and then I find box, and as I start typing, and then it's selected, I can use my up and down arrow keys, but I'm just going to go hit enter and enter again, and that makes my box. So again, I can use my Alt key to zoom in, zoom out. I won't cover those navigation shortcuts again, but here is our box. And if I wanted to do something to it, I have some basic options here. But one of the things that's really common to do in Houdini is to separate the actions using other nodes. So rather than controlling the transformations here, it's very common to, let's say, hit tab and then add, like, let's say, a transform node. Now, you notice that when I hit enter to make the node, you have to hit enter again to place the node, and then you have to like wire it up. It gets kind of annoying. So what I like to do is I like to hold shift enter. So if I hold shift enter, then it automatically adds the node and automatically wires it up for me, which is really cool. So now if I'm on the transform node, I have a lot of the same properties. I could adjust one of these values, and that value is stored in this node. So again, it's not as flexible just like grabbing in the viewport and going, although I could do that too if I wanted to. But this is the common workflow in Houdini, because all of that adjustment, that transforming, is stored in this node. So it's very flexible. Now, I go to translate, which is move, right? And I have X, Y, and Z here. And the way we typically adjust things in Houdini is we use the middle mouse button, and we click with the middle mouse button in a field, and we get this thing called a ladder. And this is a really interesting and kind of cool way to adjust values. Houdini, by the way, works in meters, whereas Houdini or Cinema 4D works in millimeters. Houdini works in meters. It was kind of built to be a simulation tool, so it's meant to have, you know, big explosions and things like that. So it's used to having bigger things, and so it works in meters. So oftentimes we need to go down to little tiny fractions in order to get the sizes that we need. But if I go up here, you'll see I'm working on ones, tens, and hundreds. So if I want to adjust this by 1, I'm still holding my middle mouse button. I drag to the right to increase by 1, drag to the left to decrease by 1s. Or I could, if I really wanted to move this much bigger, I could move by 10s or move by 100s. Or I can move by a 10th by going down here, and I'm still holding my middle mouse button, and I'm dragging left or right. Or I could go down to something really fine-tuned, like just like a 100th or even like a 1,000th. So see, it's barely moving now. So it's kind of an interesting way to adjust properties. If you want to reset something, I can control middle mouse button click on the name of the property, and that will reset it to its defaults, which is pretty cool. I could also move all values at once, like let's say scale. I don't want to have to adjust, you know, X, Y, and Z all independently. So I can middle mouse button click on the word scale, and then I could scale this up entirely. Another powerful thing about Houdini is that each of these little fields, these are called channels, by the way, that will come up later. Each one of these channels has a lot of power to it. So a very common thing to do is to create this expression that I'll show you momentarily, because what happens is you can see the grid kind of dissecting our object. And then as I scale this, it's scaling from the center. That's pretty default behavior for DCCs. If you're going to create a 3D object, it will scale from the center. But oftentimes we want it to scale from the bottom. We want the butt of the 3D object on the butt. I shouldn't say butt. I'm not going to talk. I'll talk more professionally. So we want the bottom of the object on the grid, and then we want to scale up from the bottom of the grid. So what we often do is we can go to a property, let's say a uniform scale, and I will copy this parameter. It's right there, just say copy parameter. And then let's say I'll go to the Y value, the up and down of the translate here, and I will paste relative references. So that puts, that basically makes a connection, kind of like in After Effects when you have the pick whip, and you connect it to another property, and then they're the same, they're kind of connected like that. That's all this is doing. But what I want to do is actually divide this by 2. So I put a little /2, divide by 2. So that makes it so that the Y position is being taken from half of the scale value. So now when I scale this up, I'm scaling it up from the bottom. So it's a very common little trick to do in Houdini, and it seems complicated maybe until you do it a couple times, then it's like super easy and efficient, kind of a great way to work. Now again, the flexibility here of, let's say I move this and I'll move this over to the left a little bit. There we go. So I've done some stuff on this transform node. And one of the powerful things about Houdini and these nodes is that it's procedural, and you'll hear that a lot. And that just basically means that it's very flexible because nothing is like baked in. Typically, we don't do that in Houdini. So if I then hit tab and I created a sphere, and then I wired this sphere into this, then it picks up the transform. So it has moved, it has the scale thing applied to it, and we could just substitute anything we want in here. So we could use just little placeholders, or we could just audition things. We could try and see how things work. So it's a very flexible workflow. Now, a very important part of the geometry nodes to be aware of is this little blue thing right here. This is called the render flag. And what that means is this is the thing that's currently displayed. Because in the geometry context, you can only display one thing at a time. You could only have one thing showing at a time. So if I choose the render flag on the box, then the box will render. If I choose the render flag on the sphere, then the sphere will display. If I choose the render flag on the transform node, it will show me the sphere after the transform node has adjusted it. So you might be saying, well, how do you display multiple things at once? Because that's a kind of important thing to happen. So what you can do here is I can create something called a merge node. And this is similar to Nuke, if you're familiar with Nuke. And I could just drag the box into this and drag the sphere transform into this. And then we can merge all of these together. And now we have these multiple things in our scene. Another powerful thing about Houdini is that we can reuse the output of these nodes, or SOPs, if you want to be cool, you know. We could use these outputs as many times as we want. So let's say that I want the transformed sphere to be a part of this, but I also want just the untransformed sphere to be a part of this. I could add that to the equation. I can't see that because of the box. I'm gonna hold the letter Y, which gets these little scissors, which is fun. Hold Y as a shortcut for the scissors, and then I could snip. And so there we have it. So I got rid of the box, and now we could see the sphere. So I have the original sphere and the transformed sphere both hanging out, merged together with a merge node. Okay? Any questions about that? Does that make sense?
Yeah, I feel like it's pretty cool watching this. I'm not personally a Houdini user currently, so I do know a bit about Nuke and node-based compositing, and so this is really making sense. But I guess this all goes back to our previous conversations we've had here about understanding the fundamentals and workflows as a whole.
Yeah.
Because it's starting to it makes sense. Everything you're doing
Cool.
is looking.
Cool. This should feel pretty basic, hopefully. Like, I'm trying to make this as not intimidating as possible. Like I said, I'm still learning Houdini. I've been learning it for years, and I'm actually working on a training course for Houdini, because it's just getting these basics down is really important. And once you've been using Houdini for a while, it's like you forget what it's like to learn the basics, and so it takes a lot to, even just the simple stuff that we're doing. It takes a lot to kind of process it. So I'm glad that we're all on the same page. I know this is going to be pretty slow, but we're about to ramp up. So stay with me here. Glad we're on the same page. Let's go to a different example here. Another concept. We're going to start ramping this up a little bit. So I want to show you another node that's very important, and also another thing. I'm just going to make a sphere here. Another thing that's very important about Houdini, and a lot of people are intimidated by the nodesness of Houdini. A lot of people are kind of like, oh, that's scary. But especially for those of us that are using Redshift or Nuke or DaVinci Resolve, the idea of nodes isn't scary. And also, if you are new to nodes, it doesn't actually take that long to get used to nodes in Houdini. That's not the scary part. To me, what the scary part is, and that we're gonna dig into this a little bit, is that it thinks in a different way. I'm going to go over here to the side, the right side of my my viewport, where I have some display options and stuff like that. I can display the points. I can display the number of points, so on and so forth. Now, I'm going to put this little dot here so we can display the points. This is the thing that's intimidating about Houdini, because at every other DCC, you have vertices, you have edges, and you have polygons. I mean, that's just standard across the board. But in Houdini, we do have edges, kind of, but they're second-class citizens. And we do have polygons. They're called primitives. They are also second-class citizens. Really, what Houdini is concerned with is points. And there also are vertices, but the vertices in Houdini are not the vertices that you're thinking of. So these points are not vertices. These points are called points in Houdini. And the powerful thing about these points is that we can infuse them with all kinds of data, all kinds of attributes. And that's, I think, where Houdini is much more confusing than the average DCC that's out there. And another thing that's very powerful and kind of complicated about this is that these are particles. So in Houdini, points are particles, particles are just points. So we just created a particle system. By creating the sphere, we have these points, these are particles. And then it's up to us, as we'll see momentarily, to infuse this with data that makes them move or behave in a certain way. So before we get there, let's see what else we can do with points, and this will come in handy later. Let's say that we're going to make a box here. I know I'm really pushing the gamut of creativity here by creating boxes and spheres, but this will just make it a little bit easier to see what's going on. So what I'm going to do is create a powerful node called copy to points. Copy to points. Now this one has two inputs. The left side is the geometry that it's going to copy, and then the right side is the points that it's going to copy it to. So let's say that I wanted to a box at each one of these points. So I could then drag this to the geometry that I want copied, and then we're going to use the points of the sphere. Now we're not seeing anything yet because what do we have displayed? The sphere. That's where the render flag is. So I need to change that to copy to points, and now we see this madness. So what I'm going to do here is I'm going to add another transform node and wedge it in there, just move it over, and it automatically just like hooks up once it gets close. And I could go now and scale this down, and there we go. There we have it. So we have copied these this box to all the points on the sphere. And again, it's procedural, so we can go back to our sphere and change the amount of geometry, and then we're changing the number of boxes because it's procedural. We could also go to our box and add like a poly bevel, for example, and then we can go and we can, bevel this edge, and it's all dynamic and wired, and nothing is like burned in or whatever.
So that's interesting because I'm learning Blender right now, and it's exactly the same thing with geometry node. You copy points to another geometry. It's the exact same workflow, but of course, I guess Blender just did the Houdini way. So it's very similar.
Yeah. There's a lot of copying going on out there, which is very interesting. But yeah, I'm glad that like some of this feels familiar. And I think too, I mean, this is something I was going to say later, but one of my hopes for this month, as we've gone through all these different ways to use particles natively in Cinema, in XParticles, last week in particular, like I'm hoping that we see that whenever you're learning any of these tools, it helps you learn the other stuff. We talked about this last week with like CC Particle Systems 2 or whatever. The stuff we know about particular helps us there. And same thing with this. Anything that you're taking, like that you've learned about nodes, Nuke, whatever, and anything that you're bringing over is going to help you here as well. You're going to be able to use your knowledge, which is pretty cool. So, okay, so this is all I wanted to cover with copy to points, but this is essentially how we instance our particles, because once we're at the end of the day, once we're left with particles, it's just going to be a series of points, and they're not going to render because points don't render. It's just like in Cinema, it's like an edge in Cinema, or a point, a Bezier point on a shape in Cinema, or vertices or whatever, just a vertex, they don't render. So the way that we instance those is by using this copy to points node. So we could use copy to points to create, geometric objects like this, but we could also use copy to points to instance our particles. So it seems like we're just doing basic things, but we're actually kind of slowly along the way learning some interesting things. Now let's go into this color playing thing, and this is where it's going to start getting, we're going to ramp up a little bit. So I mentioned that these points are everything, right? We could infuse these with data. And let's see how we do that. I'm going to add something called an attribwrangle. And new Houdini users, this is like the bane of your existence, but also where all the power is. And so we can, it's just basically like this empty text field where you can write a bunch of code, which I am not a coding person at all. I am not a math person. Like my math skills are like second grade level or something like that. It's bad, it's bad. So if I can pull off learning Houdini and doing some of these basic like programming things, then you should definitely not be intimidated, because it's not that hard if I can do it. So what I can do is I can call an attribute. I can reference an attribute. So I do that with the @ sign. So one of the built-in attributes, there's like a ton of like built-in global attributes, like the position, normals, things like that are kind of like just built in, even though we can't really see them. So CD is capital C, lowercase d, so it stands for color diffuse. So this is basically just like the color of the object. So I could just say color, or CD, equals 0, and you always have to end with a semicolon, okay? And that's it. So CD equals 0. Now to enact this expression, or in other words, to like to execute it, I guess we would say, I'm gonna hit Control Enter on the PC or Command Enter on the Mac, and then that executes it. And now I've turned the color black. And you might be like, ooh, yay. That's crazy.
I love how you're laughing at yourself as this is happening. It's great.
Yeah. But we did something a little bit cooler than that. And to see that, we have to go to something called the geometry spreadsheet. I hate all those words, but this is really where the power of Houdini is, and where you spend a lot of time working. Actually, this isn't like some kind of like obscure, weird, esoteric thing that I'm showing you. This is really a core thing for understanding Houdini. So what I want to show you here is that we have on the left here, if we're in this points mode, which it's very important that we are, especially for the stuff we're going through today, we can see the number of all the points. Every point has a unique ID. So we're seeing the points on the left-hand side. And then on the right side, or the bulk of this, we're seeing the attributes of those points. So we have the position X, Y, Z, and now we have the position of red, green, and blue, and it's all 0. So we have an attribute that we created, and we have a value that we've given to it, and that's important. If I go back to the sphere and I click on the sphere, you'll notice how my geometry spreadsheet updates, because there is no CD attribute yet. We haven't created it. So once I click on my attribwrangle, we can see the attribute. But if we're back here, then we're not seeing that. And you'll notice that the render flag is still on the attribwrangle. And this is the thing that trips me up a lot. It still trips me up all the time, honestly. So the gold outline is the thing that we have selected, but the render flag is the thing that we're seeing. And there's a difference there that's really important to be aware of. So we can fiddle with this more than that. Let's go back to the attribwrangle. I'll go ahead and hold the Alt key or Option key and drag this over. So we have a copy of that. And let's say now, instead of doing CD, because you saw before that we had red, green, and blue split out, because color is a vector, right? It's 3 attributes. It's not just like this is the color blue or whatever. It's like there's a red, green, and blue value for every color. So when we said CD equals 0, it's just kind of like all channels, all colored, everything equals 0 all across the board. But we could be more specific. We could say CD dot G. In other words, CD dot green. So the green channel in the colors equals 0. And I hit Command Enter, and now we have magenta. Let's see. Do I want to Okay, let's do this. And we'll just get a little brief taste of some of the power here. I'm going to copy again the original attribute wrangle, and we'll set the render flag on that. We could start doing some pretty interesting stuff with this. I could say that CD equals, let's see, I had an example that, okay, let's say this. Let's say that, oops. Let's say that the red channel, cd.r, equals at P, so at capital P represents the position, right? And we know that that attribute already exists. We just saw it in the geometry spreadsheet. So let's say that the red value comes from at P.y. So the red value comes from the y direction. The red value comes from the y direction. So we see at the top here, actually, I'll just so this is a little bit more clear, I'll just do times 2. And hopefully that's a little bit more clear. So we have more red here at the top, which kind of turns into white lighting. But as we kind of go down here, it's multiplying times 0. So we have less red, so we're getting cyan. But the point here is that I can use this color data to do all kinds of things. I can use the values from the color to control other attributes, or I can use the value of the position to control other attributes as well. So we can start doing some very interesting and very powerful tricks. And I think this is where, when people are like brains are fried by Houdini, this is where it starts getting a little bit more complicated. Let me show you one other thing that you can do that's very powerful with this. I have here a copy to points already set up for you here. And then the sphere, so it's basically the same exact thing I did before. Same exact thing, where we have a box, we're copying the box a bunch of times, we have a sphere, and then we're copying the boxes to the spheres or whatever. But let's say I want more control, and I'm gonna turn off this view of the points. It's getting kind of annoying. Let's say we wanted to control the scale of the cubes. So we actually control that by infusing the points of the sphere with scale data. So I'm going to go to here, and I'm going to go to attribute wrangle, and I'll add an attribute wrangle. I'll put that here. And the attribute here that we're going to use is called p scale, point scale. Yeah, right. That's fine. Yeah, p scale makes sense, and that's the scale attribute. But what I'm going to do, I'm going to create my own custom interface. So what I'm going to do here is, let's see, what did my notes have? Okay, maybe we'll skip that for the sake of time. Okay, I'll just call this. So what I need to do is create the name of the slider that I'm creating. And because it's a string, like it's gonna be like text characters, we don't want it thinking that it's like a program or some kind of executable function or whatever. So we put it in parentheses and then in quotes. So like, I'll call this my very, I don't think it respects case. So I'm just gonna say my very own slider, and then I'll put the close parentheses and then a semicolon, and then command enter, nothing happens. Matter of fact, we lose our thing, which is not great, because we use this ch thing, this channel call out, which means that we wanna make our own slider. And there is no slider yet. We have to go to this button over here, which when I click it, I clicked and I have my very own slider that I made, which is the simple expression. So now I can go over to this slider and be like, and I can use this to adjust the scale as I please. So anytime you want to create your own slider in Houdini, you just type ch in parentheses and quotes, put the name of it, and that's it. So anytime you want to like multiply something by a multiplier, you want to make a new ramp, make a little slider, there you go. Easy peasy, right? That's pretty cool. Let's do something different. Let's do something even more powerful. And this is going to be, if your mind is like not blown yet, that's good. But this might be where the mind starts getting blown just a little bit. But stick with me or rewind, and you know, it'll make sense. So what I'm going to do is I'm going to go to P scale, but instead of controlling it with just a simple channel slider, which is just kind of like a dumb thing, which is like everything big, everything small, to controlling the scale uniformly across all of the things, I want to be able to control the scale of the cubes in my own way across the y-axis. So what I can do is I'm going to create something called a channel ramp. So this is similar to CH, but it's going to create a ramp that I can play with. So here I need to, I'll call this point scale. And then I need to put a comma. And then I also, for creating a channel ramp, I need to reference, like, where am I getting this data from for this ramp? And I want to, like I mentioned, I want it to be over the y-axis. So there we have it. So I'm creating a channel ramp called point scale that is using the y-axis, that's going over the y-axis to control the P scale. So I can hit Command Enter, and then we know we have to hit this little button for channels and channel ramps. So hit that, and now I have this slider, and this is where the fun comes in, because I have all kinds of control now. So I can go to this point and I can, you know, move it here, scale it down. I can click here and move this down, click here and move this up, and I have all this control over how I want this scale to land across my object here, which is pretty powerful. So that's kind of a cool way to control things in Houdini. And again, you saw it's really not a very complicated thing. We just need to say, like, what data, which property is getting which attribute is getting the data, which is P scale, and it's controlled by this channel ramp, and we have to name it and talk about where it's getting its value from. And that's it.
Yeah, everything is very logical, actually. It's yeah, it's very, very, very interesting.
Cool. Are there any questions yet, or any kind of business like that?
One interesting question about Houdini Indie. Is it worth a visit, or is that version limited? It's a question from Jay Eddington. And I answered that it's definitely great for learning. I don't know the limit. It's limited, but it's very useful to learn. And actually, it's not at all restricted. You can do a lot of stuff with it. I don't know if you have used it.
Yes, I actually have a Houdini Indie license as well. So yeah, the Houdini Indie license, basically, it's for people that if you're making, like, if your shop makes less than like $100,000 a year or something like that. So if you're a student, if you're just learning Houdini, especially if you're not like out there, like Houdini Indie is like really, I think it's like $200 something a year or something like that, or $400 for 2 years, somewhere in that ballpark. And really the only restriction, I think, is that a monetary one. You're not, like, it's a licensing one where you're not allowed to use this in big productions or on stuff that makes more than $100,000 or something like that a year. But I think functionally, I think it's the same. It's the free version that Apprentice, I think they call it still. Yes. That license is a little bit limited, but I don't think the Indie one is. Good question, though. Yeah, I think the Indie is definitely worth it, because you can do simulations and like all that kind of stuff, and you can do simulations and stuff like that in the free version too. But like when you export, you know, it has the watermark, and it's like 720p is like the biggest resolution. You can't export VDBs and things like that. So, okay.
Thank you.
All right, are we ready to keep going here? We're just about to get into the good stuff. I'm gonna go into this. Okay, here we go. This is VOPs. This is where things start getting a little crazy. So there's another thing called VOPs, and VOPs is short for VEX operators, and VEX is the kind of the programming language that we use when we're in Houdini most of the time. There's a few programming languages. You could use Python and stuff like that, but in most places in Houdini, most of the time you're gonna be using VEX script. And so kind of like Espresso with Cinema 4D, we can use VOPs as kind of like a visual way to kind of assemble code and do some interesting things with code. So I'm going to create something called an attribute VOP. And we're going to do this, again, to teach about VOPs, but also this is like us starting to make particles here. This is going to become our particle system. So VOPs is another context, another world. So I double click this and I'm in a different world. So at the object level, then we created a geometry network, we're in that network, and then inside the geometry network, we're in this like VOP network. So it's kind of nuts. But again, if you're intimidated by coding, this is kind of like a helper because this effectively is like an attribute wrangle, except the syntax is backwards. So in an attribute wrangle, you say, okay, here's this thing, here's p scale. And then you say, here's what it is, and you define it. The syntax of VOPs is backwards. So we start with the data, and then we plug it into what it means at the end. So I could say the CD, the color, let's get it from the position. So I can drag P to CD, and now the color of our object comes from the position. So again, the syntax is backwards, but it's doing essentially the same thing. We can take a bunch of data, get it from wherever we want, and then plug it into our final output. And so these are some basic properties that come with Houdini that are just kind of there by default: position, velocity, yada, yada, yada. So I'm going to go ahead and hit Y to get my scissors and then chop that. And we're going to add some noise. And I'm going to go through this pretty quick because we're running out of time. I want to create some anti-alias. Okay, so this is a cool thing, a cool trick. When you're in this tab thing, the node I want to create is called anti-alias flow noise. Now that's a lot to type. I could type ANTI until I get it, and there it is. But the search thing in this field is actually pretty cool. I could type AN, and then if I realize, like, you know what, I'm lazy, I don't want to type all this out, I could then start typing acronyms. So just like anti-alias, FN, flow noise, and there we go. That's the only one that comes up. So I could type the first letter of each thing. I could type a hybrid of like some letters of some words, and then like the initials. I don't know how it knows, but it somehow very intelligently knows what I'm trying to say. So I could then add an anti-alias flow noise. And what we're going to use is basically, this is a fractal noise pattern. And we're going to, and I could tell you the whole thing now, it would make sense. We've talked about the color attribute and stuff like that. So what we're going to do is create a fractal noise pattern that's moving around our sphere. But it's also going to create a color attribute that we could use then with particles. So I can change the signature to 4D input 3D noise. And that's the first thing you want to do with this node. This node is kind of weird. So the first thing you want to do. So the three things, just like Cinema 4D, the fourth D is time. So we have X, Y, Z, and time. So there isn't, if you notice that these colors represent the type of data. So like integers are blue and float values are green and so on and so forth. And these just turn this kind of like weird lime shade, which is like a quaternion. It's 4 values. So what we can do here, since we don't have any of that business going on here by default, I could hit tab and create a node called a vector to vector 4. So this just takes a vector and combines it and makes a little lime green thing here. So we could put this here. And I'm going to raise this up a little bit. Maybe I could just move this and resize briefly. So I'm going to take the position, put that into the vector thing. You see the colors match, same type of data. Then I'm going to take the time data and put that into the 4th value. And now we have a quaternion that we can put into one of these other matching line grade things. So I'll say the position there. And there I have it. So then I can take the noise and I can output this to the color. And if I press the up key, you can see that we have moving noise, which is pretty cool. Okay, we're quickly running out of time here. Let's see. Let me just show you this really quick. If I select the anti-alias flow noise, I get the values for it. And one of the things that's very common to do, like let's say well, you know, when you're messing with fractal noise patterns, you never know, like, you know, the size or the contrast, those type of values. And it's really annoying to have to like find the VOP node when you're in SOPs and then dig into it and try to find the node in the VOPs and then the attribute. It's just really annoying. So what I can do here is go to, let's say, flow rate, like the speed. I can, with this node selected, see its attributes down here in the properties panel, the parameters panel. Go to flow rate, go to this little sprocket here, click that, and I can choose promote parameter. Once I do that, this goes gray. I can no longer do anything about it. And then I also have this little tab right here, like a little sticky note tab. And that lets me know that this property has been promoted. So when I hit the letter U and go up, and I go to my attribute VOP and I scroll down, behold, flow rate now has been promoted to be accessible in SOPs. So I don't have to go digging down through my network to get to this attribute anymore, which is pretty cool. So now if we go to the geometry spreadsheet and we move this in time, look at those CDR or those RGB values. Look at those values. They're moving all over the place. This is data that we can use. Do we want this color? No, of course we don't. This is disgusting. We don't care about this color. But because we are using, you know, this noise map to create these shapes and patterns, we could then use this data to do other things. Okay, so let's go up and let's go into the particles intro. And so here we have like a finished version of this noise thing that I made. And now what we want to do is we want to add a new network, yet another network. But all of the stuff, all the magic that we have with particles and simulations happens in something called the dynamics context, the dynamic environment, the dynamic network. And so that's where we have like explosions and fire and whatever. They're trying to, the makers of Houdini side effect software, they're trying to like take more stuff out of DOPS, the dynamic network, and put it into SOPs because this is where we spend most of our time. It's not quite there yet, but there's increasingly more things that we can do. There's like a pyro solver in SOPs. Anyways, so I'm gonna hit tab and I can hit pop and we can create a pop network. And as you can imagine, pop is particle operator. So I'm going to create a particle operator. Instantly our geometry is gone. And now we have particles that are birthing, they're coming on. So we got something here. Now I can double click here. Now we are in the crazy world of DOPS, where the rules are completely different and things don't work as we would expect them to from what we've learned about Houdini thus far. So the reason why these particles just kind of like grow on like this is because they don't have any velocity. They don't have any velocity just yet. So what we could do is go back up and very quickly, let's make an attribute wrangle, good buddy attribute wrangle. And let's say at V, that's the velocity, lowercase v, equals, I don't know, let's just say CD. Let's just say the velocity is equal to the color information. Okay, and then this goes orange because I'm at frame 20, and that's letting me know, this orange lets me know that this is not cached. So we have to go back to the beginning, and then let's preview this, and now look at that. We have a particle simulation because what we did is we created this color thingy, and now the velocity is driving the velocity is being driven by that color information that we created. So the direction of the particles, the force of the particles, it's all coming from the color data. And if we go to the geometry spreadsheet with this selected here, with this one selected, you can see that now we not only have a position array and a color array, but we also have now a velocity array in X, Y, and Z for every point. And you can see that it matches up with like the CDR matches up with the X of the velocity. The green matches up with the Y, and so on and so forth for every particle. So this is where Houdini becomes potent. And okay, so I'm gonna skip some of the other stuff that I was going to show you. I will say that, so this doesn't render. If I render this now, this doesn't render, but we have our good buddy Redshift here. And if I dive in here, well, there's this other thing that I made. We'll just skip over that for now and render this. I went back into VOPs and I bypassed this. I couldn't make up my mind, honestly, whether I wanted to go straight from the noise to the color information or do this, which is what I did in this example, where I created something called a vector to float, which takes a vector input and splits it out into 3 different outputs. So it takes X, Y, Z from like position, and then splits it out into 3 different outputs. So you could change the X, Y, and Z individually. And so if I did that, then I can use one of the grayscale channels, in this case, the Y. If you see here, this is the Y coming in. So we have a black and white noise from, there we go. And then this is the final result. Oh, another thing that's really important that I skipped over. If we go inside the popnet, this is where we get a lot of control. I created a popdrag node, which creates drag and creates air resistance. So I did that so I can have a lot of velocity, but then it's kind of like slowed down by the air. And then also on the pop source node, this is where we can set our birth. So I increased the birth rate to 10,000. And one of the things that really baffles me about Houdini is the default life expectancy is set to 100, and that's in seconds. So the default life expectancy of particles in Houdini is 100 seconds, which, you know, I'm used to After Effects. That feels like 12 years. Like, I don't know if I'll still be alive in 100 seconds. So I set the life expectancy down to 2, so 2 seconds. And that's important. So if I just have these particles, what I can do, come up here, select the geometry node in the object context, the upper level, and there's actually a Redshift shelf. If that's not showing, you can go to this drop down and you can go to shelf sets and you could choose, no, that's not where it was. I could go to plus, I think. Yeah, there we go, plus. And then I can make sure that my Redshift shelf is showing. And once your Redshift shelf is showing, which is a fun tongue twister, there's this thing, which is OBJ Parms, OBJ plus. So this is essentially the object, the Redshift object tag in Houdini is what it looks like. So we select this and then select our node and then hit the OBJ button. And then it adds a Redshift OBJ, like the tag equivalent, essentially. And so then I could go to the particles tab and I could choose render object as particles. So even though we haven't done any instancing or whatever, or copied the points for our particles, Redshift can render these as particles. And what I'm going to do quickly here, I'm going to go to this little drop down and I'm going to split this pane at the top and bottom. So now we have 2 panes here. And then I'm going to right click on the scene view and I'm going to change this to the Redshift render view. And then I can click play. And all of these controls should look familiar to you if you're familiar with Redshift and Cinema. And we have that. And the first time you do this, you know, it takes a little bit. And also, if you don't have lights, it takes a long time because you're just going to see blackness. And I do have lights here. I created an RS dome light. I created a sphere light inside. And I created kind of like an edge light, a blue edge light. So we have that here. There we have it. So same thing, you know, if you like, I created a dome light here, and the settings, if I click on this, are all the same as they are in Cinema. Well, almost all. There's like little tiny differences, but basically this is the same controls, same everything that we're used to. So we don't even have to really instance our particles. We can let Redshift handle that on the render, which I think is like a really cool trick. Now, if we want to create materials, what I need to do is go up here to the top. I'm in the object level, drop down, and I'm going to go to the matte context. That's the material context. I've already created a material here, but let's not worry about that. I'm going to hit tab, and then I'll just say Redshift, or I could say RS. And then let's see, RS standard material. So I can create an RS standard material. And then what we have here, we open this up. This is, and actually, you know what I want to do? Now I want to do an RS material builder because if we do an RS material builder, kind of creates yet another sub network, and I double click this, and this is kind of like VOPs. So we have our output node, we have Redshift, open this up, we have base properties, we have all the things that we're used to seeing when we're in Redshift. And from here, I could even hit tab and look at this. Our good buddy RS Maxon Noise is here. And so we can wire this into like the base color, anything that we want to do. And then in the object level at the top, we can select our node and then go to, what is it? Render. There we go. The render tab. And then if we click this little thing here, this allows us to go to our networks, and there's the mat network, and select a material. And so that's one way you can apply materials to an object. For the final, I just instanced some different geometry and did some other stuff we don't need to get into. But for the sake of time, I'm going to move on to Unreal, since we're already over time and I haven't gotten to Unreal yet. So let me open this up. I already had this like project. This is gonna be very quick. I realize that everyone's brains are probably fried. And is there any questions about like Houdini Redshift while we're waiting for Unreal to launch?
There is a question that interests me a lot also from a Mariume. I'm sorry if I don't say your name correctly. So how you designate the axis for velocity when your particle are emitted? What is the axis for them?
So if I'm not mistaken, velocity, the axis is built in, like the velocity is a direction, right? Velocity is a force, yes, and a direction. So just in this example, we took our velocity, well, we had this, this example uses a different expression that we didn't have time to get into. But this one, it's just the velocity is the color. So it's just taking that and select all of the direction, everything that's related to velocity is coming from the color information. Okay, so you can tweak the color information, or you could additionally add another line of code that says, move it more in this way or whatever.
So you're right. My answer wasn't right. I said it would inherit the normals from the sphere, but as it's a color, like you said, it's a vector, so it has a direction and a speed already. So yes, it makes sense. Yes. It comes, and the velocity comes from the color.
Yes. Also, what's up, Ko? Good to see you, buddy. It's been a long time. I love Ko. Ko's great.
It was for him.
There's just so much to cover. There's like so much I'm like leaving out, and there's a lot of things we could get into. Another thing that I was going to do if we had time, and I'm apparently going to do it anyways, is I could say that the velocity equals the normals, and that creates an interesting shape as well. And so it's just taking whatever the direction the normals are, and it's making the velocity just come from that. So this is the power and the confusion and the wonder of Houdini, that anything could be anything. You could take data from wherever and just put it wherever. So, and a lot of times that's one of the challenges of Houdini, because they don't give you a lot of tools, because they're like, oh, you'll just write it. You could just write it. And so then you have to kind of know how things work and exist, and it can be kind of frustrating. Okay. So very quickly in Unreal, I just want to show you that these particles exist here. This is going to be very unsatisfying, probably. But I'm in Unreal 5. If you're in Unreal 4 or previous versions, they had two different particle systems. They have Cascade and Niagara. So if you're in Unreal 4, you might see both of those side by side. In Unreal 5, they've completely done away with Cascade, which is their old system, and now it's just Niagara. Niagara is very powerful, allows you to use multiple emitters and do a bunch of stuff and create some really robust particles. And so I can go to my content drawer, and let's say, okay, I made a new folder, and click Add, and make a new folder. And so in a blank space here, somewhere in my content browser, in my folder, I can right click and choose Now, what I really want to do is create a Niagara system. That's the right answer. But oftentimes, what'll happen if you're me and you forget, you'll go to the effects submenu, and you might create a Niagara emitter, and then let's just say we'll create a new emitter, and I'll just say this is found. And then if I try to add this to my system, add this to my scene, I get this like, no you don't, bucko symbol on my cursor. So what I need to do is right click on this and create a Niagara system. That's what you need to do. You need to create a Niagara system. And then that emitter will be in the system, and I could take my system and I could add this to my scene, and now that works. Now, I'm going to delete that because that irritates me for some reason. It feels like some kind of torture to watch that thing go. But if I double click the system, then we have the option to fiddle with this and adjust this. I can hold down the right mouse button to kind of pan around here. And we see a lot of the things that we've seen previously. So we have like the emitter spawn. I'm gonna take like just 2 minutes really quick, just a couple properties to fiddle with. So emitter update is like stuff that about the emitter. So the spawn rate is here. And let's say I'll take this down to like 40. And then I can go to the particle spawn, and this is where we have like velocity, and by default it's set really high. So I can take this down to like 10 and 20 as a minimum and maximum. And now we have gravity, like really yanking this down. So I could go to gravity force and uncheck this, and then it's compiling. So now it's just kind of like, you know, going really slowly here. And I'll go ahead and pause this playback here. And where are we going to go? We're going to go to particle spawn, initialize particle. So this is like the settings at birth, the particle spawn area. Some of that's found in the emitter update, some of that's found in particle spawn. And so like the color, for example, I could click on this and select the color here. I could also go to this drop down and maybe change this to random range linear color or whatever if I wanted to use like a gradient or something. And then another thing that's really cool is that we could change the object here. So I go to like shape location, and instead of a sphere, I could, let's say I'll make a torus. So now we have like a torus of particles. Play here. There we go. So now we have like a torus of particles that's rendering, and we can just stop right there. But that's all I want to show you about this. But I wanted you to be aware that, you know, a lot of these attributes, you know, about using sprites and the velocity and all these things, these are attributes that we see in TrapGood particular. They're absolute attributes that we see in Xparticles and Cinema and Houdini as well. And the benefit of Unreal, and why I wanted to show it, even though it doesn't really do it too much justice because we couldn't really get into it, is that this is rendering in real time. So kind of putting everything together, you know, when we learn something about a particle system, it helps our knowledge of particles. But as we saw with Houdini, it can take a bit to render those particles. So by fiddling in Unreal, we can learn about particles and explore and experiment and kind of play around and do that in real time. So we don't really have a render hit. So this is kind of a cool way to learn about particles, again, in real time. And it's a little bit more of an education when, like, as you're changing an attribute, you can see the difference that it's making. So kind of a cool way to do particles. Anyways, 9 minutes over. I don't know. I'm not feeling great about that, but it could have been worse. With all the content that I was planning on showing that I had to like eliminate on the fly, I'll take it. It's fine.
You did great, I think. I mean, it's Houdini and Unreal in 1 hour. I mean,
yeah, it's kind of it was kind of a dumb task I gave myself.
I mean, it wasn't so bad. What I like about it is that there's so many different connections between all of these different softwares. And,
yeah,
you know, like, I feel like it's something we can't really harp on enough, is that, you know, once you learn, you know, the fundamentals or the basics of different workflows, software pipelines, things of that nature, you know, a lot of these different tasks, you know, in various software start to make a lot more sense. You know, there's been plenty of time, you know, that I've spent in the industry just helping people in another software package that I've never used before. You know, and it just comes from the base knowledge of, you know, having used different things. So, you know, let's say render engines, if you're going from Redshift to Octane or Octane to Redshift back and forth, a lot of things are similar. You know, different particle systems, you know, say X particles to Houdini to Unreal, certain things are going to start making sense. So yeah, it's great to see a lot of this come together.
Yeah, when I was done with Ellie's Redshift thing that she did in February of this year, which if you're looking to learn Redshift, I mean, that is the best way to do it. It's like a 6-part series, or maybe it's just a 4-part thing on Redshift. It's just mind blowing, so helpful. And then I came into Houdini, and it's like Houdini became a completely different program because all the Redshift stuff made sense, lighting made sense, camera stuff made sense, and all of the stuff that I learned from her webinars about how to assemble particles or how to assemble materials, it all worked in Houdini too. So yeah, just learning stuff in any place, it does just elevate your overall game, I think.
For sure, definitely.
I agree. It feels very familiar to Blender, so I don't think I don't find Houdini so scary now because it reminds me the way you just plug particles onto an object. It's very, very similar. And of course, scene nodes in Cinema 4D are very similar too. It's a little different each time, but the base concepts are the same.
Mm-hmm. Yeah. Base concepts are the same.
I see Jay's question here. When does the making sense actually kick in?
I'll let you know.
Yeah, right. I'll let you know. It's definitely it's not the first time I've actually gotten that question because I like to say that, you know, there's, you know, a lot of things in art are really just experience based, and experience is obviously just built from doing it. You know, so if you're a beginner user, I oftentimes really implore people to get to know a software. So it doesn't matter really whether that's Blender or Cinema 4D, you know, like whatever software you're wanting to create in, learn that software, learn the tools that it has. And then as you start to dive in, like Lionel's moving into, you know, learning workflows in Blender, super important to know how nodes work. You know, scene nodes and geometry nodes, all of these things. If you don't know how they work, period, it's going to be difficult to learn anyway. So learn things in a software, then start to branch out and move on. And experience is just experience, and that's exactly where making sense comes into play.
Yeah, exactly.
It's a process too, you know, like when I was setting this up, you know, this Houdini stuff, when I was setting it up, I felt so polished. It was like I finally felt like, oh, I'm actually comfortable in Houdini. Like all this stuff makes sense. I didn't have to like look stuff up much. Like I just like I got it. And I was like, okay, I know this stuff. But this morning, as soon as I got in, I was like, I have no idea what I'm talking about. I have no, like this stuff is just like at the edge of my learning capability. I'm looking at this like copy to points thing, and the orientation of these things, these spin, and it would take, I don't know how to fix that offhand. I would have to like go and sit and figure out, and like that's like beyond, just like the most simple tasks are beyond me. So like as I'm teaching this stuff, I'm like, I have no idea what I'm doing. So I mean, I think it's like, but I think like if I were to look at the Chad from like 3 years ago, it's like, oh no, I know what I'm doing more than that guy did. But you know, it's just kind of like this gradual procedure that you just, it's a journey and not like there with no end destination. Like it's a journey and a direction with no
we're lifetime students. Like that at the end of the day, like that's what you are as an artist anyway. You know, I like to tell my students a lot, you know, like the difference between a professional artist and a beginner artist is experience. And the more that you know, the more that you learn and you practice and practice, the better you become at troubleshooting. And that's really like the biggest definition, or, you know, as far as I'm concerned, like the difference between a pro and an amateur is like understanding how to troubleshoot. And it doesn't all have to be wrapped around knowing a software inside and out and every little technical thing. It's much more about like the steps that you take to problem solve, because we have those things all the time. And Chad, you're 100% right. Like this is like, I would look at this and I'd be like, I have no idea, man. Like you just script some Python something or other and put that in there and then rotate back. Like,
Yes. Yeah, I think it's important to remember too that, like, you know, we're artists. Like when I'm looking at Houdini and I'm looking at like the rotation of these cubes, like, do I need to know the rotation of these cubes on this sphere to teach? Yeah, that would have been helpful. Do I need it to in order to express myself and create some kind of like art for like a project? Not right now. I mean, I haven't needed that yet. So like, you don't have to necessarily like know everything. You need to know what you need to know. You know, you need to know what you need to know to make the stuff. But then like everything else above and beyond that isn't as integral to what's going on. So, I mean, if you look at Houdini and you're like, you want to feel like you know everything, you know, then, you know, best of luck to you. But, you know, I don't think that that's really necessary in order to create beautiful art and make something that expresses you, you know, that you're creating for a client or whatever.
yeah, 100%. Like I'm all for, you know, like objective based learning. And that's for me, the quickest way that I learn a software. You know, if I were to pick up Houdini and say, want to have some crazy vortex of debris doing something or other, like I would focus on that and figure out how to do that. And then you learn so many different things along that, you know, that process. You know, and that's how I like to learn. I like to trial and error, and usually more error. And so you like truly fail forward with it, because there are a lot of things, you know, like Unreal, for instance. That's one thing that I'll be, you know, starting to dive into. And, you know, Chad will probably be the guy that I'm like, hey, I have this thing. How do I solve this problem? You know, so, but that's also where, you know, community is such a huge thing. And I love the 3D community for that, you know, as being able to answer questions, ask questions, get inspired. It's great.
That's awesome. Well, thanks guys. Dustin, Lionel, thank you so much for being here this whole month. And Ellie, we miss you wherever you are and hope you're enjoying yourself. And thank you everybody for joining us in all these sessions. Like, you make these sessions amazing. So please get your free shirt if you want to do that. And yeah, we hope to see you in other future webinars. And I think that's it for this month, guys. It's been a really fun time. It's been really great.
Is it over already?
Great.
I know, it's always so crappy. It always is a miserable thing.
All right.
But
well, that
yeah,
sounds good.
thanks so much for joining us and bearing with us as we went 18 minutes over. And we'll see you next time, everybody.
All righty. Bye, everyone.
Take care.